Notes 9C. Writing exponential functions. Objective. I can write exponential functions given a graph or word problem. Essential question. What do I need to write exponential functions? Let's talk about some words that you'll see when they're talking about either growth or decay. So here's a picture of growth. It's also known as appreciates, increases, grows, gains, doubles. For decay, here's our picture. It depreciates, decreases, degrades, loses, halves. Write equation given a graph. Is this picture a growth or a decay? When we look from the left to the right, it's going away from the horizontal asymptote. That's a growth. The horizontal asymptote is a horizontal line that almost touches this blue line. It's at y equals -3. The y-intercept is right here, 0, -2. So your equation here is y equals a parentheses b to the x power. So we have the base to the x power -3. Let's look at the next one. Write equation given a word problem. The salary of a typical WNBA player appreciates at a rate of 4.5% per year since 2000. The salary in 2000 was $27,000. So when we do our BHS, we're going to first box the numbers. We have 4.5%. The original year was 2000, and the salary was $27,000. Since the original year was 2000, we're going to say that t equals 0 at the year 2000. Next, we will highlight our keywords. So we see the word appreciates. That means that it's going to grow. Appreciates means grow, so that means it's a growth. Our initial amount was $27,000. And the base is going to be 1 plus our rate, 0.045. So to set up our equation, we have f of x equals our original amount, 27,000, times 1 plus 0.045 to the x power. And what's the salary in the year 2013? So for x, we're going to plug in 13. The sketch of our graph would look like this, where this point is 27,000. So in our calculator, we're going to type this in and then put parentheses 13. So basically, in the calculator, we type this. 27,000 parentheses 1.045 close parentheses to the parentheses 13th power close parentheses, right, enter. And then we press enter. We get $47,849.30. Let's look at another one. The population of zombies grows by 24% each month. The number of zombies in the population is now 35. Our first step, box the numbers, 24% and 35. Next, we want to highlight the important keywords. So we have grows, and then now. So it grows, so that is a growth. Next, we will identify our givens and our unknowns. The population is now 35. So we'll say that's the initial amount. The base is 1.24. It grows, so we're going to sketch a graph of a growth. And the original is 35. So our formula would be f of x equals our original amount 35, parentheses 1.24 to the x power. We're going to find the population after 11 months. So instead of x, we plug in parentheses 11. So in the calculator, you're going to type 35, parentheses 1.24, close parentheses, caret, parentheses 11, close parentheses. Right, enter. When you put that in the calculator, we get about 373 zombies. A car purchased for $27,000 is expected to lose value or depreciate at a rate of 4.5% per year. First, we box the important numbers, or all the numbers actually. In this case, they're all important. And then we're going to highlight keywords. It's expected to lose value, depreciate. Rate is per year. So since it's losing value, that's a decay. The initial amount is $27,000. The base is going to be 1 minus 0.045, which is 0.955. So let's set up our function. We have f of x equals 27,000 parentheses 0.955 close parentheses to the x power. What's the value of the car after 5 years? Wherever we see an x, we're going to plug in a 5 instead. Parentheses 5. So 27,000 parentheses 0.955 parentheses caret parentheses 5. Close parentheses, press right, and then enter in the calculator to evaluate this. Based on this formula, the value of the car is expected to be around $21,447.70. If we're to draw a graph of this, it would be decaying with the original value at 27,000. Let's look at one more. Patty bought a laptop computer for $765. The value of the computer depreciates about 22% each year. So our numbers are 765 and 22%. Let's go ahead and do our keywords. We're going to highlight the keywords. So they bought the computer. That was the original value. It depreciates. It's each year. So from here we know the initial amount is $765. This is the decay because it's depreciating. And the base is going to be 1 minus our rate. So we have 0.78 is our base. So for a function, we have f of x equals 765 parentheses 0.78 to the x power. What's the price after 6 years? Plug it into the calculator to evaluate. 765 parentheses 0.78 close parentheses caret parentheses 6 close parentheses, press right, and then enter. To get the price is approximately $172.28 after 6 years.